Does our sun have a deadly nemesis that dooms life on our planet? Among the unexplained mysteries in the universe, one has a particular urgency for those of us who enjoy living on planet Earth. Do Earthlings have a regularly scheduled date with extinction? And if so, what causes this periodic hard rain of destruction?
You have this enormous explosion. Anything within thousands of miles will be killed. You're talking here first of the blast wave, of the tsunami. You have this enormous explosion. Anything within thousands of miles will be killed. You're talking here first of the blast wave, of the tsunami. You're talking about the enormous heat. Fires all around the globe. And then darkness.
For millions of years, enormous objects from space have slammed into Earth with disastrous results. One impact in the waters of the Yucatan Peninsula is blamed for the extinction of the dinosaurs 65 million years ago. But this wasn't the first mass extinction on Earth, and it probably won't be the last.
And it wasn't the biggest mass extinction event of all time, because that one was the Permian extinction, in which 95% of the species in the oceans died and about 80% of those on land. So radical extinction events have happened.
Some scientists believe these periods of death and destruction happen like clockwork.
Some paleontologists found a very strange pattern. What they found were the great extinctions, such as the ones that killed the dinosaurs, but others too, didn't happen at random times, but seemed to occur on a regular time schedule. That was very strange.
Astrophysicist Richard Muller believes the explanation for this periodic destruction is a dim red dwarf star lurking on the edge of the solar system. A star that he fittingly calls Nemesis. According to his theory, Nemesis is an undiscovered companion star to our own sun. It travels between 1 and 3 light years from the center of the solar system on an elongated elliptical orbit. As Nemesis makes its closest approach to the sun every 26 million years, its orbit takes it right through the Oort cloud, a collection of an estimated trillion comets surrounding our solar system. That's when the order of the solar system turns especially chaotic.
When that happens, Nemesis gets close to the comets and perturbs their orbit.
According to Muller's theory, the gravitational disruption caused by this small, innocuous star causes long, undisturbed comets to break away from their orbits in the Oort cloud. Pulled towards the sun by its gravity, 1 billion comets are sent careening toward the inner solar system. A handful inevitably cross paths with the Earth, resulting in massive impacts and mass extinctions. The claim that our sun has an undiscovered companion Death Star is controversial. Most scientists believe that the sun is a solitary star with no companions. But in the universe, binary or even triplet stars grouped together by gravity are the norm.
The majority of stars in our galaxy are parts of either binary or triple stars. And so the idea that the sun conceivably could be part of a binary isn't crazy from that point of view at all. It's an interesting question.
Even if the sun could conceivably have a binary companion, astronomers have never observed a binary system in which the pair of stars are as far apart as Muller claims our sun and Nemesis would be. Muller needed proof that Nemesis was real. In 1997, a NASA mission began that had the potential to shed light on the mystery. The 2-micron all-sky survey, or 2MASS, used twin infrared telescopes to scour the universe for previously unknown stars. 2MASS specialized in hard-to-find bodies in and near our galaxy, and to date has produced over 2 million images. If Nemesis was out there, 2MASS should have spotted it. But the survey never detected anything fitting the description of Muller's Death Star.
We've looked real hard for Death Star, for Nemesis, and we can't find it anywhere.
Nemesis may actually be a brown dwarf. These failed stars are much smaller than red dwarfs. And with a highly elliptical orbit, a brown dwarf would remain far from Earth most of the time and out of the watchful eye of astronomers. If that's the case, Nemesis could have easily slipped under the 2MASS radar. Richard Muller vows to continue looking and plans yet another, more detailed study. He believes it's only a matter of time before Nemesis is found.
There are lots of stars out there. There are millions of them. But when you find a needle in a haystack, you can look at it and say, well, that's not hay. Similarly with this, when we find Nemesis, we'll measure the orbit and we'll prove that it's Nemesis.